All right, what's good, everybody? How's it going? Today we are moving on to chapter 3, which is going to be on triangles. Fun fact, triangles, one of my favorite shapes, really intriguing, very interesting. So, chapter 3 is on triangles. Our first lesson in triangles. We're actually not going to talk too much about triangles in lesson number 1. We're going to talk about congruent and corresponding. Okay, so before we get going, if you log into Canvas, okay, here on the homepage, I've uploaded some new chapter 3 things. Obviously, there's no lesson videos yet because this is the first one I'm making right now. But here's the notes that go along with this video. You can download them, print them, or download them and type on them. And then here is the PowerPoint that is also being shared. Okay, so congruent, we already learned in chapter 1, but just to talk about it some more, congruent means the same size and same shape. The symbol for congruent is an equal sign with a little wave on top, okay? The wave talks about the shape, the equal sign talks about the size, right? So the congruent is an equal sign with a little wave on top. Okay, and congruent lines. How can we tell if lines or angles are equal or congruent to each other? Right, the answer to that is if we have congruence lines. All right, sometimes I call them little tick marks, sometimes I call them little bubbles, but the actual technical term of them is congruence lines. Right, when sides or angles have the same amount of congruence lines, that means those sides or angles are congruent to each other. And we just said the congruence means the same size and same shape. Right, so if we look at these two triangles, we can see here that line AB, right? This line right here, notice it has one little tick mark. We look over here, it matches one little tick mark. So line segment AB would be congruent to line segment DF. Again, apologize, terrible writing. That's a D. All right, line segment DF. Okay, another example. Let's take a look. This angle right here, angle B, right, has two little bubbles in it, right? So look over here. We see that this angle here has two little bubbles. So that means angle B is congruent to angle E. All right, that's how you can tell if things are congruent to each other, is if they have matching congruence lines, right? So that would mean, I'm not going to write all of these out, but line AB, it has two tick marks, is congruent to line DE because it has two tick marks. Line CB has three, line FE has three. They are the same, they are congruent, right? Angle A is congruent to angle D, angle C is congruent to angle F. All right, so congruence lines helps tell you what sides and what angles are congruent to each other. All right, so given the following picture, what side lengths and what angles are congruent to each other? Go ahead and pause the video, think to yourself, answer these questions. Hopefully you pause and answer those, right? If we're going with lines, check them out. One segment matches with one segment. So line LK is congruent to line YX. All right, segment line LM is going to be congruent. It has two tick marks with this one, line YZ. All right, and the last one, line segment KM is going to be congruent to line segment XY. And then you can do the same thing for angles, right? Notice both of these angles, maybe this wasn't the best example. All of these angles have one segment, right? But they also have numbers on it, okay? So you would know that angle 1 is obviously, congruent to angle 1, so on and so forth. Angle 2 is congruent to angle 2. Angle 3 is congruent to angle 3, right? I apologize. This actually wasn't a great example. It should be angle 2 should have two tick or bubbles. Angle 3 should have 3, right? Because they are the same. Sorry. So that one was a bad example for the angles. The line segments was still good though. Okay, now corresponding sides and corresponding angles are a pair of congruent angles or congruent sides that are in the same spot but in two different shapes, okay? So in this example, corresponding sides, side length BC is corresponding to side length IJ, right? They are congruent. They're in different shapes. They have different names, but they're in the same place in congruent shapes, right? Angle, and for corresponding angles, this example is angle A is corresponding to angle X. So when we say corresponding, that means they are also congruent, and it also means that they are in the same location, just in different shapes. Okay, these two examples are pretty easy because their orientation is exactly the same, right? They're not flipped, they're not rotated, nothing really has changed, right? But over here, notice you still have corresponding even though the shapes are in different orientations, right? Angle G is congruent and corresponding to angle R, even though they are in the angle G is in this lower left corner and angle R is in this upper right corner, right? They are still congruent and they are still corresponding, okay? Same thing, angle S is congruent and corresponding to angle K. Angle P is congruent and corresponding to angle F. Notice here they only gave two options for the side lengths. So we can write in that third one, GS, right? Side length GS here is congruent and corresponding to RK, which is there, right? And sorry, if I want to be more accurate, I should use congruence lines. Line segment GP, GP is 8, right? Congruent and corresponding to RF, which is also 8. And then if we wanted to use a third one, right? It's not written here, but we see that line segment PS, right? Line segment PS would be congruent and corresponding to line segment KF or FK. Okay, so that's just another example. Okay, when we say that things are congruent to each other, we use them calling a congruent statement, right? A congruent statement is stating that a line segment, an angle, or whatever we're talking about, or an entire shape is congruent to another. However, the order of the letters is very important, as corresponding parts must be written in the same order, right? So take a look. If we go back, right, notice when we say that side length GS, right, is corresponding and congruent to RK. Notice G and R are the congruent angles. So notice G and R have to go first in this example. S and K are congruent and corresponding angles. So S and K in this example has to be written second. Okay, I always tell you, or we learned in chapter 1, that the order when you name things doesn't matter, right? But when you're talking about congruent and corresponding, the order does matter. We could have written line segment KR is congruent, but now since we put K first, we have to put S first in the other one, right? Line segment SG. Okay, that's why it's important to make sure that you are writing the same letters that correspond with each other. Okay, so example, state which line segments are congruent and which angles are congruent. Okay, so it's really easy to do angles, right? We see that one bubble matches with one bubble, so that means that angle F is congruent and corresponding to angle K, right? And both of these are right angles. Both of these are right angles, right? So we can see that angle G is congruent to angle L. Okay, notice angle M and angle H do not have congruency lines, right? We will learn further on in this chapter that we would be able to prove that those would end up being congruent to each other. But right now, since we don't see any congruency lines there, we cannot assume that those are congruent until we learn how to be able to prove that, right? So right now, I'm not going to write down that angle H and angle M are congruent, even though they look like they are, because right now, we haven't learned any ways of proving that those are true. Okay, now let's take the line segments. Right, we see one tick mark, one tick mark. We know that those side lengths are congruent to each other, but we have to make sure we write them in the correct order, right? So I'm just going to choose any order I want for this one. Line segment AML is congruent to, notice, now I have GH, right? But they have to be the same. Notice M did not have any congruence lines, or angle M doesn't have any congruency lines over here, and angle H, right? So since I put M first here, I have to put H first. HG. Okay, same thing. I could have done LM and then I would have to switch it to GH as well, right? So then let's take the 2 marks, right? 2 marks, 2 marks. Okay, I'm going to call this line segment LK is congruent. Now think to yourself, pause the video. What has to go first in these 2 letters over here? Is F going to go first or is G going to go first? Okay, hopefully you thought about that. Notice angle L has the right angle, and that's what we put first. So we have to put G first because it also is the right angle. So it has to be congruent to segment GF. Okay, and the last one, the 3 tick marks matching 3 tick marks. Again, doesn't matter which one I choose first. Let's go ahead and choose segment KM. Think to yourself, what has to go first in the other line segment? Is F going to go first or is H going to go first? All right, since we put K first, that matches up with F, so we have to put F first. There you go, right? So these are the correct and accurate ways to write them. Remember, the corresponding parts have to go in the same order. Okay, same thing happens when we talk about the entire shape as well. All right, same thing happens when we talk about the entire shape. So triangle BCA is congruent to what? Right? We know it's going to be congruent to the other one. We see that we have multiple different sides. It's the same. Okay, so we're going to call this triangle. All right, so BCA is what they already said. We have to label and we have to put these orders in the correct order, right, to match. Well, we see that angle B on this triangle is also congruent to this angle B in that triangle. And since B was first there, B is going to go first here. C was the second one. C is down here. Which angle is congruent to C? We see that T is congruent. So since C went second, T has to go second. And lastly, A is also going to be, we notice, all right, that has to be a right angle because that creates a straight line. One right angle is 90 degrees. This other right angle, or this other angle, even though it's not labeled as a right angle, we have to know that it's also 90 because 90 plus 90 gives us 180, right? So that the order has to be triangle BTA. Okay, now coming over here, triangle QRS, right? QRS, notice that is QRS. That doesn't make any sense at all. There is no R in this thing. So that's really annoying. We're going to change this, ladies and gentlemen, to QAS. All right, we're going to change that to QAS because that actually is what the triangle is called. Nice. Shout out to Mr. Stanton not checking these things before he puts them in his notes. Anyways, QAS over here, right? So Q goes first. Notice we have one tick mark, or sorry, one congruency line in this angle Q. Notice we're not going to use angle Q first for the second one because there isn't, right? It's not matching. The one that actually matches here is angle T. So we're going to say that T goes first in this triangle. Okay, second is A. Notice A has 2 bubbles, right? 2 bubbles. Which angle matches with 2 bubbles? Angle P does. And then S is labeled last. There's no congruency lines. Which angle has no congruency lines over here? Q doesn't, right? So even though Q was listed first in this triangle, Q ends up being listed last in this triangle because angle Q right here doesn't have any congruency lines, and that matches with angle S in this triangle that doesn't have any congruency lines. Okay, and remember, these are just one specific, or I guess 2 problems, so 2 specific ways that you can do it, right? It doesn't matter the order in which you start naming your triangles. You just have to make sure that the opposite triangle, the congruent triangle, is listed in the same corresponding order, right? So some other ways we can do it. Let's go back to our first example, right? Instead of calling it BCA, the first triangle, let's call ACB, or let's call it ABC. Let's make it easy. Triangle ABC is going to be congruent to what? Well, we have to use the same letters. Angle A here corresponds with angle A there. So we're going to call it triangle A. Which angle corresponds with angle B? Well, angle B corresponds with angle B. And then which one corresponds with C? T corresponds with C. So triangle ABC is congruent to triangle ABT, and it has to be named in that order. Okay, let's try a different way. In the other example, let's call angle or triangle PTQ is going to be congruent to what? Okay, pause the video if you want. Try and answer that on your own. Which one matches with angle P, right? Angle P has two congruency lines. Angle A has two congruency lines. So we're going to call it triangle A. Which one matches with T? T only has a single. Q has a single. So we're going to match that with Q, right? And then if we have Q in this first one, right, Q in this triangle has no congruency lines. S in this triangle has no congruency lines. We have to name that AQS. Right, that is a different example, a different way. Notice you could do it again in a third, opposite, different way, as long as your angles are corresponding and in the correct. Okay, so you have to make sure that the angles are corresponding and in the correct order. It matters. It makes, it makes a difference. Okay, now we're tying together what we learned in last chapter into this chapter, right? In chapter 2, we learned about transformations. There are two types of transformations, isometric and non-isometric. Remember, isometric transformations are defined as transformations where the image does not change in size or shape. Okay, we just got done saying in this unit or in this lesson right now that same size and same shape means that they are congruent. Okay, the three types of isometric transformations that we learned about last chapter are translations, reflections, and rotations. Therefore, we can conclude that if we can perform an isometric transformations, the shapes must be congruent. It is a proven absolute mathematical fact that if you can perform an isometric transformation, those two triangles are or any shapes for that matter, are automatically congruent, right? And shout out to being able to prove things, okay? Here's a Khan Academy example video showing how if you rotate a triangle, they are congruent to each other, right? And here's a short, cool activity. Okay, so given the pictures, could you draw a line to cut the shapes into two congruent halves? Okay, I want you to think about this. Okay, this first one, it legitimately gave me issues at first as well. If we draw our lines right here, though, right, we see that we end up with two congruent shapes. How do you know that? 1, 2, 3, 4, 5, 6, 7 boxes. 1, 2, 3, 4, 5, 6, 7 boxes. Okay. This one, how can you cut it in half? Where can you draw lines to have two congruent halves? This one ends up being right here. Okay. And this one also gave me issues, right? It was pretty difficult to see. How can we cut it into two equal parts, two congruent halves? And it ends up being right here. Okay, again, 1, 2, 3, 4, 1, 2, 3, 4. Okay, which then tells us how can you prove legitimately without a doubt that the two halves are actually congruent? What did we just get done saying? What did we just get done writing? If you can perform a transformation, right, then you can prove without a doubt that these two halves or these two new shapes that we've created are actually congruent, right? So we see here that all we've done here, ladies and gentlemen, we've gone 2 to the left, we have gone 1 down. This is a translation of -2, -1. That's all we've done, right? We slid it to the left 2 spaces, we slid it down 2 spaces. I'm going to start using a different color. Okay, this one, how can you tell? How do you know for sure? Well, if you think about it, if we're cutting it in half right here along this line, this ends up being a reflection. What about this one? What kind of transformation is done here? Well, if you think this is, let's call this shape A, and if this shape were to be A prime, this one would end up being a rotation, right? We rotate it this direction, okay? And it's not really important now. Chapter 2 is already over, but think to yourself, would that be a positive rotation or a negative rotation? Right? Is this clockwise or counterclockwise? We are actually going counterclockwise here, so it would end up being a positive rotation. Okay. And if you don't see it after you rotate it, your shape would end up, I mean, I'm not drawing on dots, so it's not as good. It would end up looking exactly the same as A prime. Okay, look for a similar activity. I'm going to try this out. So this whole chapter, we are given a bunch of materials that's it's very project based for this chapter. I truly believe that learning through projects is super beneficial. I also am cognizant of the fact that it's going to be really difficult being able to do these things while we're through distance learning, and if you're at home, whether you're online. So I'm going to try our best. We are all going to try our best to try and make these projects work. I think it could be really beneficial, and plus projects are really fun. Honestly, that's one of the best things I like about geometry is that it's very project driven. You can do a lot of things with it. So it makes me a little bit sad knowing that it'll be harder to do projects while you're away and if you're online. But we're going to try our best. We'll figure it out as long as we work together. This is our first lesson for triangles. I hope you have a great day. I'll see you in class. Go Mustangs.